Patterns and rules. Well, let me begin by putting a couple of pictures into your mind. One is the image of the honeycomb, an image that many of you may be familiar. The honeybee, you remember, has a home built of hexagons. As you observe the pattern of the hexagons, it's easy to see that the observation of the various pieces, it's mentally related to actually, the whole pattern, the whole house, the whole honeycomb. Well, the second image is the nautilus seashell with its expanding equiangular spiral segments. As you look at it, you can see that as this pattern is observed, its various pieces must be grasped and appreciated as a whole, because if you look at just one segment, just one little segment like right here, well, the beauty of it disappears. Well, as you begin your journey through the study of patterns, of numbers and their behavior, you'll see that these patterns are all around you. Your first assignment on arithmetic sequences and geometric sequences are two of the basic patterns that occur in numbers. As you will learn, these two sequences are often found in life that is not man-made. Alright, so by examining a wide range of patterns, we notice regularity, variety, many ways that these topics can interconnect. We can also see that certain patterns occur again and again. There are many types of patterns, repeating patterns, sequence patterns, and special patterns like the Fibonacci numbers. Some patterns can be represented using rules or functions, while other patterns can be represented both numerically and geometrically and help us link arithmetic and geometry. Well, a particular type of pattern in which numbers, objects, letters, or geometric figures are in an ordered arrangement is called a sequence. Sequences are classified according to the methods used to determine subsequent terms. There are two common types of sequences. They are the arithmetic sequences and geometric sequences. The sequence 1, 3, 5, 7, 9, 11. This is an example of an arithmetic sequence. The numbers, objects, letters, or geometric figures that make up the sequence are called the terms of the sequence. An arithmetic sequence is a sequence of numbers in which each succeeding term differs from the preceding term by the same amount. This amount is known as the common difference. So if you look at this example here, the 1, 3, 5, 7, 9, 11, in this example, each succeeding term can be obtained by adding 2 to the preceding term. Okay? And then in this example, the common difference is 2, because 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and so on. So the nth term of an arithmetic sequence can be found by using the formula an equals a1 plus n minus 1 times d. Okay, so where n is the number of terms that you want to find, a1 is the first term, and then d is going to be your common difference. Okay, so let's look at an example. Let's say that you need to find the 8th term of an arithmetic sequence that begins with 5 and has a common difference of 9. So that looks like 5, 14, 23, 32, 41, 50, 59, etc. And we're trying to find this 8th term. So we're going to use the formula. So in the formula, we're going to substitute a1 with 5, n with 8, and d with 9. Okay, so this is what our formula is going to look like after we put in our substitutions. Okay, we're going to follow the order of operations. So we have to do what's in the parentheses first. So we only have one set of parentheses, so we're going to deal with those first. So 8 minus 1 is 7. So in the order of operations, we start all over again. Do we have any more parentheses? Nope, we don't have any parentheses that we need to do anything in. So then now we want to look for multiplication from left to right. And yes, we do have multiplication. So we're going to go ahead and do the multiplication. So 7 times 9 is 63. All right, so we're going to start all over again with the order of operations, and we don't have any parentheses left. We don't have any exponents. We don't have any multiplication. So now it's just addition left to right. So here we go. We're going to just add 5 and 63. So that gives us 68. So our 8th term is 68. So if we put 68 up in here, you can see that if we add 9 to 59, it is going to give us 68. So the other type of sequence is the geometric sequence. So in a geometric sequence, instead of the same number being added to each term to obtain the subsequent term, the same number is multiplied by each term to obtain the subsequent term. All right, so rather than having a common difference as the arithmetic sequences do, geometric sequences have what's known as a constant multiplier or a common ratio. All right, so in this example, each succeeding term can be obtained by multiplying 2 to the preceding term. So we take 1, we multiply it by 2, we get 2. Take 2, multiply it by 2, we get 4. Take 4, multiply it by 2, we get 8. Take 8, multiply it by 2, we get 16. And then our next number here is going to be 16 times 2. So that's our geometric sequence. All right, so the nth term of a geometric sequence is an times r to the n minus 1 power. Okay, so a is going to be the first term and r is going to be the common ratio. So let's look at an example. All right, so say we need to find the fifth term of a geometric sequence whose first term is 1/2 and whose common ratio is 6. All right, so this is what we're looking at here. 1/2 and then the multiplier is 6, so 1/2 times 6 is 3, 3 times 6, 3 times 6 is 18, 18 times 6 is 108, and then so on. So we're looking for this fifth term here. So we're going to substitute in the formula. For a, we're going to do 1/2. For r, we're going to do 6. And for n, we're going to do 5. So this is what our formula here looks like. So again, we're going to follow the order of operations. Go ahead and do what's in parentheses first. So this one really, we're just going to subtract 1 from 5, and that gives our exponent now is a 4. All right, so our next order is to do exponents. So we're going to do our 6 to the 4th power first. So that is 1296. And so now we're going to multiply. So half of 1296 is 648. So the fifth term is 648. So something interesting just to kind of give you a little bit of an outlook on or an overview of the arithmetic and geometric sequences. The terms in a geometric sequence increase or decrease much more quickly than the terms in an arithmetic sequence. This type of growth, you'll probably hear it as exponential growth. And when it is a decrease, then it's going to be known as an exponential decay. So you may hear those terms throughout your studies, okay? So exponential growth and decay occur when the change between the terms is the result of multiplication, not addition. All right, so that's just something to keep in the back of your mind. Okay, well that concludes this video on sequences and patterns. So that concludes this video on patterns and rules.